All right, this is the review sheet for the Chapter 3 test, and so let's just get right to it. I'm going to work through all of these problems, and the first one is a multi-part problem where we have to look at a quadratic function and come up with several different answers. So let's get right to it. Letter A is identify the y-intercept for this function, and that's pretty easy to do. All you have to do is look at this last number, the constant. The constant is a number without a variable, and so my answer for letter A, the y-intercept, is -6. Letter B, I need the equation for the AOS. Well, the formula to get that equation is this, the opposite of B over 2A. So make sure you're careful with this formula. Remember the opposite of, and just double check yourself. A lot of people make a mistake and they end up with the wrong sign, and their entire graph is on the wrong side because they're just not careful with this little formula. So opposite of B, so again, A in this case is 1, B is -1. So it's the opposite of B, which is -1 over 2 times A. So I'm going to do the opposite of -1/2, which is +1/2. Notice it says the equation for the AOS. So I need the equation for a vertical line, and so that's going to be x equals +1/2. And since I'm going to end up graphing all of this anyway, I'm going to go ahead and sketch out where x equals 1/2 is. Okay, so letter C, identify the vertex. Well, when you find the AOS, you've basically found the x-coordinate of the vertex. So now we just have to find the y. And the way we find the y is we just put our x-coordinate in for x. And if you go to your calculator and do this, you're going to get -6.25, or -6 1/4 is the vertex. So I'm going to go ahead and plot that. The vertex will always be on your AOS, 2, 3, 4, 5, 6, and then just a little bit below that. Just a little bit below -6. Okay, let's see, what else do we have? Letter D, is there a maximum or a minimum value? Well, since this parabola opens up, I know that because the A number is +1. That means it's got to open up, which means the vertex is on the very bottom of the parabola, so I'm going to have a minimum. It's all about where the vertex is. The vertex is on the bottom, so I got a minimum. And the value it's talking about is the y-coordinate of the vertex. So when you find that y-coordinate, you're actually going to have 2. That's going to be used for 2 answers. So that's letter D. Letter E, use the graph to provide the solution to x squared minus x minus 6. So let's go ahead and finish our graph. We know that the y-intercept is -6, so I'm going to plot that point and then match it up on the other side. Okay, and so I'm going to do a little table of values to come up with other points. So let's input 2. Okay, I need a point for x equals 2. So I'm just going to do some mental math here. So you might want to use your calculator, but it's 2 squared minus 2 minus 6. That's 4 minus 2, which is 2. And then 2 minus 6 is -4. So the point 2, -4 can be graphed. That's on my graph. And I'll just match this up. It's 1.5 units away. So I'll just go 1.5 units in the other direction from the AOS, and I've got a matching point. All right, let's do another input. I'm trying to inch my way closer and closer to the x-axis. So let's input 3. All right, just so you can see that. So 3 squared minus 3 minus 6. 9 minus 3 is 6, and 6 minus 6 is 0. Okay, so I have a definite place where I'm crossing the x-axis. I don't have to guess. It's an integer. It's going to be 3. That's one of my solutions. And then I'll get the other one just by looking at my AOS. So that's 2.5 units away. So 1, 2, 2.5 units. And so now I'm ready to sketch my graph. I missed that point, but it's not always easy to use this board. Okay, and if you've got, so let me go ahead and finish and then we'll talk about use the graph to provide the solutions. So my solutions are x equals 3 and x equals -2. And if you've got time, if you finish the test and you want to come back and you're trying to see if you did this correctly, you want to make sure that your letter E is correct, just use another method. This also can be solved by factoring. The factors of -6 that add up to -1 are -3 and +2. So if I solve this by factoring, I'm going to get the same thing. So I feel pretty confident I've gotten the same answer. My solutions have been arrived at correctly in 2 different ways. So that gives me some really good assurance that I've done this correctly. All right, so we've done letter E, now letter F, domain and range. So domain is going to be all real numbers. And then the range will be only y's that are from -6.25 and going upward from that. So we're going to include -6.25 and all the y's that are getting bigger than that number. The graph is going up. Okay, so that is the complete answer for number 1. So let's take a look at the rest of these. Number 2, we're simplifying these complex numbers. So I'm going to offer a suggestion to you. I would get rid of the parentheses by distributing -1 to this second number. So -1 times 7 is -7. -1 times 6i is -6i. And now just combine like terms. And for complex numbers, notice, these are complex numbers. Do you see how the real number is in front of the I number? That's always true for complex numbers. So when you write your answer, I want you to do the same thing. So 3 minus 7 is -4, and 1i minus 6i is -5i. And so that would be my answer for number 2. Number 3 is addition. These are not quite as tricky as subtraction, so really you just look at the like terms and combine them. -4 plus 5 is 1. -9 plus -7 is -16i. So be careful on your test. Know when to use FOIL and when not to use FOIL. Just pay attention. Notice these are not multiplied. This is subtraction, this is addition. I don't use FOIL for either one of these, but I do use FOIL when I multiply. Okay, so first, outer, inner, last. First, 3 times 5. Outer would be 6i plus 6i. Inner would be minus 20i. And then the last would be minus 8. 4 times 2 is 8. And then I squared. But remember, I squared is -1. So when I combine these I terms, 6 minus 20i is -14i. And then when I take care of replacing I squared with -1, it makes this -8 times -1, which makes it plus 8. And now combining the numbers 15 and 8, I get 23 minus 14i. So that's my answer for number 4. For number 5, I need to change this square root of -5 or -25 first. So remember, this is multiply here. And this isn't the distributive property 3 times both of these. It's just 3 times the square root of -25. So I need to change the square root of -25 into its I form. The square root of -25 is 5i. So notice I'm not multiplying 3 times 4. Just times 5i. So now I'm just going to write this in its correct form, and I'm done. So 4 plus, and then I just multiply 3 times 5i, and I get 15i. That's my answer for number 5. Number 6, you got a couple of different ways of doing it. You could go ahead like we did up here, replace I squared with -1, and it makes it look like that. And negative 3 times negative 1 is positive 3. And then you just have to multiply 2i times 3, and you get 6i. That's your answer for number 6. For number 7, for these complex numbers that are in fraction form, we're going to have to use the complex conjugate. So I'm going to multiply the top and the bottom of this fraction by 2 minus 3i. Distribute 4 on the top. 4 times 2 is 8. 4 times negative 3i is negative 12i. And then on the bottom, if you did FOIL, you'll notice that the outer and the inner parts will cancel. So just do the outside. 2 times 2 is 4. And minus 9i squared. That's the last terms. But again, we'll go ahead and take care of rewriting the numerator. But simplifying the denominator, this is like negative 9 times negative 1, which makes plus 9. And so then my denominator is going to be 13, 4 plus 9. And for complex number fractions, we just want to break them up into the real number fraction and then the imaginary fraction. So that's my answer for number 7. Number 8, really there's two different ways of thinking about this. You could think of this as the complex number 0 plus 2i. So you would use the complex conjugate negative 2i. So that's staying consistent with using this conjugate. So I'll just stay with this method. So distribute negative 2i times both. So that would be negative 12i. And this would be plus, negative times negative makes positive, and it would be 2i squared. And then down here, this would be negative 4i squared. Now we need to always simplify I squared. So I'll just come down here. This is negative 12i. And if I let I squared be negative 1, it's like 2 times negative 1, which is minus 2. And then this is negative 4 times negative 1, which makes positive 4. So let's put it in its correct order. Real number part, imaginary number part, and now reduce. So negative 2/4 is negative 1/2, and 12i divided by 4 is 3i. Okay, that takes care of 1 through 8, and here's number 9. So whenever you have I raised to a multiple of 4 power, it's always equal to 1. So I to any multiple of 4 power. If it's not a multiple of 4, let's just say, I'll say 50. Well, 50 is not a multiple of 4, but 48 is. So I could rewrite I to the 50th like this, knowing that I to the 48th is just 1, and we've already talked many times how that I squared is negative 1. So I know that's not on your review sheet, but just trying to give you an idea that anytime you have I raised to a multiple of 4 power, it's always equal to 1. So that's the answer to the review sheet problem. Okay, so a couple of different ways of going about this. You could just go ahead and take them the first two. That would make negative 12i squared. But since I squared is negative 1, it's really negative 12 times negative 1, which is positive 12. And then multiply positive 12 times 2i, and you get 24i. Okay, so solve this equation. So let's get x by itself by subtracting 27 from both sides. Now we're going to do the square root of both sides because I need to get rid of this power of 2. If I do the square root of both sides of an equation, I have to include plus minus. So now I'm going to simplify the square root of negative 27. So I'm going to show you in radical factors how to break this up. So I've got to use the square root of negative 1 because it's negative. Then I'm going to use the square root of 9 and the square root of 3. So these have to multiply together to equal this. And these first two radicals can be simplified. Square root of 9 is 3. Square root of negative 1 is I, and then this third radical stays radical. That's my answer for number 11. Okay, solve by factoring. Use the box method when applicable. It's not applicable unless you just want to on number 12. You don't have to, but you do have to on 13 because the number in front of x squared is greater than 1. So for number 12, I'm looking for the factors of negative 15 that add up to negative 2. And that would be negative 5 and positive 3. So now I just let each of my separate factors equal 0 to come up with the solutions. Remember, solving is not just factoring. Factoring is involved, but don't just factor and stop. Give me the two solutions that you're supposed to come up with. And here they are, positive 5 and negative 3. Okay, box method here, so I'll just come down here and do it. 2x squared goes here, negative 5 goes here, multiply those together, and now come up with the factors of this that add up to negative 3x. That's negative 5x and positive 2x. And put those in the other two empty squares. Find your GCFs, x and 1, 2x, negative 5, and that tells you what your factoring is. And it's a good idea if you've got time to double check, use FOIL, and make sure you can get back to this. So 2x squared plus 2x minus 5x is negative 3x, and negative 5 times 1 is negative 5. So the factoring looks good. Now just take each of your separate factors, set them equal to 0, and solve for your two solutions. So 2x is equal to 5, x is 5 halves. Here, x is negative 1. All right, completing the square. We need a perfect square trinomial. This isn't because 8 doesn't have a perfect square root. So I'm going to get rid of 8, move it to the other side using subtraction, and it's going to be replaced. It's going to be replaced by a number that has a perfect square root, and it makes a perfect square trinomial, and that number will be added to both sides. Well, how we get that number is we do the square root of x squared, bring down this sign, and always divide whatever's in front of x by 2. And now the number that goes in the blank will be, in this case, negative 1 squared. Negative 1 squared is 1. Negative 8 plus 1 is negative 7. And now I do the square root property. Just like we did in a previous problem, I'm going to do the square root of both sides, plus minus for the number. The square root of the left side just makes x minus 1, and this is plus minus. Don't forget, if you do the square root of a negative number, you have to simplify with the number I. And now to finish off my answer, I just add 1 to both sides. And that's my answer for 14. 15, similar problem. I'm going to get rid of the positive 11 by subtracting 11. Replace that number. So let's see, what will it be replaced with? X plus 4 divided by 2. 2 squared is 4. So I'm going to be adding 4 to both sides. And similar answer. Got negative 7. Okay, square root of both sides. And this time I'm going to be subtracting 2. And that's my answer for number 15. Okay, using the quadratic formula, let me just write the quadratic formula. If you don't have this memorized, work on it. You're going to need it. So this is the quadratic formula. Make sure the equation is in standard form first. And I'll just go ahead and label the A, B, and C parts. So here's A, it's 1. B is 8. C is 5. Okay, so the opposite of B, that's negative 8, plus minus the square root of B squared. 8 squared is 64. minus 4 times 1 times 5. And all of this is going to go over 2 times 1, which is 2. And now we'll simplify the radical part. 64, and make sure you before you subtract, make sure you multiply all these together. So remember, multiplication comes before subtraction in PEMDAS. So that's going to be minus 20 over 2. And that's going to be the square root of 44 over 2. I need to simplify the square root of 44, and I'm going to use the perfect square root square root of 4 times the square root of 11. And when I simplify this, I get 2 times the square root of 11. And now I can reduce because 2 divides into all of the non-radical numbers. And when I divide 2 into each one, I get negative 4 plus minus the square root of 11. There's an invisible 1 here. 2 divided by 2 is 1, and then there's an invisible 1 denominator. Okay, now they're completing the square problem, but before I can not complete the square quadratic formula problem, before I can use the quadratic formula, I have to get this in standard form, which means I'm going to have to add 10 to both sides. All right, so here we go again. The opposite of b, which would be positive 6, plus minus square root of b squared. Be careful here. When you square negative 6, you're going to get positive 36. That number should never be negative. When you square a negative number, it's always going to be positive. Minus 4 times 1 times 10, all over 2 times 1. 6 plus minus, this is going to be 36 minus 40 over 2. 36 minus 40 is negative 4. The square root of negative 4 is 2i. And I can reduce because all of these are divisible by 2. 6 divided by 2 is 3. 2 divided by 2 is 1i. And you don't ever have to write denominator 1. So 3 plus minus I is my final answer. All right, little word problem. Going back to chapter 1, I want to know if you can write a linear equation that represents a real-life scenario. So identifying variables, a linear equation looks like y equals mx plus b. So your job is to figure out which of these numbers represents m and which one represents b. That's basically what this amounts to. And we're going to let our variables be set up as x is the number of pamphlets delivered, and y will be how much she earns. Okay, well, how much she earns depends on how many pamphlets she delivers. And in this case, the 17 cents is going to be considered slow because it's going to affect how much we earn. The $35 is fixed. It's not changing. It's a fixed number. But I'm going to be changing my y number based on 17 cents times every pamphlet that's delivered. So just kind of talking you through how to come up with this little equation. So see if when you get your test, make sure you can identify, given these two numbers, which one is a fixed number and which one do you think would represent the slope. It's going to be multiplied times the x, the unknown. It's going to represent a change in this y value. All right, so we've got the equation. So now, using this equation, how much will she earn? In other words, what will y be if x is 300? So show me on your test how you use the equation that you came up with in letter A. So if you need your calculator, it's 0.17 times 300, and then add 35 to that, and she gets $86. So try to answer a word problem with words. All right, takes care of 18. 19 is a system of linear inequalities. So I need to get them solved for y first. I'm going to subtract 6x from both sides. Then I'm going to divide by -2 on both sides. And when I do that, that causes me to reverse the direction of the inequality. Okay, so now that I've got it solved for y, I can plot the y-intercept, -6, and use a slope of +3, up 3, right 1. And it's going to be a solid line because it says or equal to. Okay, so this boundary line looks like this. And now I'm going to do the red. Same thing, I'm going to get it solved for y. So subtract 3x from both sides. Divide by 4 on both sides. And same thing, start at 3 on the y-axis. Count a slope of -3/4, up 3, left 4. Down 3, right 4. This one's going to be dotted. Because it doesn't say or equal to. And now I'll do the shading. So I'm going to be doing greater than the red, which greater than means above the line. But I'm going to be doing less than the black. So the area where it's both greater than the red while at the same time less than the black, below the black, that's all of this, all of these ordered pairs. Any ordered pair in my yellow shading would be considered a solution. And that's your answer for 19. Okay, 20 and 21. If you're given a function and I give you the input, that's what this says. If you input -3, what would the output be? So just look at how x got replaced with -3. Do the same thing over here. And then simplify. -4 times -3 is +12. So the answer to f of -3 would be +4. If you're graphing, that means the point -3, 4 would be on this graph. Don't have to do that, just wanted to connect it to something else. So here's a function. What's the output given an input of 5? So that just means in place of the x's, you're going to put in 5 and then simplify. So be careful here, you got to do powers first. So this is 25 times -2, it's -50, minus 20 plus 1, -70 plus 1, -69. So on this particular parabola, the point 5, -69 exists, is what that really says. But all you have to come up with is the output. I'll give you the input, you tell me the output. I'll give you the domain, you tell me the range. Okay, so number 22 is a piecewise defined function, so I'll just color code these. I'll do this first one in red. It's the line y equals 2x plus 3, so start with a y-intercept of 3. Not cooperating. And then a slope of 2, up to right 1, down to left 1. Right, all of those are on the line, but according to this, we're only showing part of the line. We want to start where the x coordinates on that line are 1, and that's right here. This is the red dot that has x coordinate 1, and since it doesn't say or equal to, that dot's going to be an open circle. And this dot actually isn't even going to show up. So I'm going to show the line going in the direction where the x coordinates get smaller than 1, and that's going this way. Okay, next problem is, I'll do this one in blue. Okay, let's graph the line y equals negative x plus 2. So here's y-intercept 2, slope of negative 1. But instead of showing the whole line, show it only for x coordinates that are between 1 and 2. Well, here's where x is 1 on this blue line, and here's where x is 2 on this blue line. So really, all I'm going to show is all the x's in between, and I'm going to include x is 1 and x is 2 because it says or equal to. So these are solid circles, and all the other points you can just erase. And I don't need that one there. All right, 2 down, 1 to go. Let's do this one in green. This is a constant. Y equals 3, crosses the y-axis at 3, goes forever left and right, but not according to this. We start at x is 2, which is right here with an open circle, and we draw the line in the direction where the x's are getting bigger than that. So it's going this way. Okay, define your domain and range. So domain in this case is going to be all reals. All of the x-axis would be covered when you put all these graphs together. That's not true for the range. The range would start at positive 5 and get smaller, and we're not even going to include 5 because this is an open circle, so 5 isn't going to be a part of the range, but all the numbers less than 5 would be. Okay, I think this is it. So this is the parent y equals the absolute value of x. This is the parent y equals x squared. And I want to know if you can give me the new equation that represents the transformed parent. So 23 represents a translation. That's just a fancy word for shift. So the parent, y equals absolute value of x, would do this. Well, that's terrible, but it would just start at the origin, up 1, right 1, up 1, left 1, forever. Okay, but this is taking the parent and shifting it 2 to the left. So if I want to show a left or right shift, I put that inside the absolute value. And the way I show shifting to the left 2 is with plus 2. Tricky. Plus means left, minus means right. And the way I show a vertical shift is I put that outside the absolute value, and plus means up, minus means down. So my answer for 23 would be this. For 24, this is the quadratic parent. That the parent would look something like that. It has a vertex at the origin. Well, this is the parent that's been shifted 1, 2 to the right. So instead of this, which was 2 to the left, I did x plus 2. This is going to be x minus 2, 2 to the right, and 3 up, plus 3. And notice that it's the parent flipped over. And when it's flipped forward like this, upside down, that means we put a minus in front of the parentheses. And that shows, that's called a reflection, a vertical reflection. All right, and I think we've covered them all. So I hope this helps you. Study hard, work hard, and come ready to do well on tomorrow's test.